Hello everyone, are you able to hear me? Please respond through the questions window. Hello Jitender, are you able to hear me clearly? Ashish, are you able to hear me? Can you respond please? Hi Ashish, could you are you able to see the questions window? Alright, alright, I'm starting now. Great. So today we are going to discuss. Hi Harsha, great. Hello Mehdi. Alright, so today we are going to start with learning Python. Alright. So, although the Python is a pretty straightforward, simple language, and we had discussed till what can you do with Python yesterday, all right? So, you can do almost everything with Python, as simple as that. And who is supporting it? There is something called PyCon, as in Python Consortium, where there's a group of people. It's a foundation who is taking care of Python. And there's a Python enhancement process because of which it's being enhanced continuously. Nevertheless, so the best way to learn Python is to start downloading it and then starting with the interpreter. Okay, you can go straight away to Python and then start downloading it. In your case, in case you are not able to install it, you can directly use it on our servers. And let's say you can simply go to Hadoop 3. Okay, Either you can download it or and install it, or you can simply go here and say Python. Alright, so when you say 2 plus 3, you can see that it is giving us 5. That means it's working fine. So this is probably your most simple program. Okay? Alright? Till the point you set up Python or your machine, you can just right away use Hadoop 3 or some other machine to get started. Alright? So my Python interpreter is running in the third window. Alright, let's try the second one also. We can say print hello world. We can say print hello and world. Alright, so it's working fine. So this Python interpreter, it can execute one statement at a time. Alright, if you want to get out of it, you can say exit, and that's it. So is everybody able to run Python interpreter? Ashish, are you able to run Python interpreter? Okay, so Harsha is asking for the password. So you can go to your login. You can see this. Yeah. The username is Park1 and password either you can show or simply copy to the clipboard. Alright. I would not like to show the password because this session is being recorded. Alright. Till the point it gets downloaded, you can continue using our server. Okay. Alright. Those who don't have the password, I'm sending them the password. Okay. Gaurav, did you receive the password? Alright. Is everybody in? Is your Python interpreter up? All right. Uh, Harsha, maybe the copy pasting may not be working correctly. So maybe you will have to type the password. Okay. All right. And in this screen, when you type the password, nothing is generally visible, not even the asterisk. All right. So Mehndi, is your interpreter up? Great. Jitender, Ashish. Okay, okay. No problem. All right. So the benefit of this terminal is that you can open it from even a iPad or your tablet and then start to experiment with it. Awesome. So most of you have your interpreter up. All right. The best way to learn a programming is by doing it. Otherwise, I mean, when we say learning programming, it essentially means that you know how to get started. Okay? Because in case of programming, most of the time you will be searching here and there, and you will be looking at Stack Overflow and getting your work done. But to start learning a programming, you should be able to know how to basically start a interpreter, do the basic coding, know the basic syntax. All right. Rest is a long term. Learning a programming language takes considerable amount of time if you have to learn it properly, but the basics you can quickly learn. All right. All right. So we use Python interpreter for if you want to quickly test. It's for good to try and learning, and it works like a shell or command prompt for scripting needs. For lots of works, this interpreter will be your very quick way to do the automation. Okay. Okay. So everybody is able to say, "Hey, hello world." So Jitendra, that password must be working. You might have to type it instead of copy pasting. Okay. That copy pasting doesn't seem to work inside Windows browsers. And I just logged in using that same thing. Let me try to show you again. Hadoop 3.nobigdata.com, and I'm saying Spark 1 and the password which you have typed back to me. Alright, it didn't work. The password is case sensitive, and Jitender, the double P is capital. Okay, you have you have given a wrong password. So, all right. So everything is capital except for small u. Doesn't work still? Wow, interesting. Wow. Actually, if I'm doing a copy pasting, it's working. Wow, try copy pasting. I don't know what's wrong with uh, me typing. This is crazy. What can I try? Alright, let me try to. Never mind. So, okay. So the problem is it's small l, not I. It's a small l, not I. Okay. So, alright. So it worked for everyone. So the basic problem was it looked like I, but it was small l. Now from here you can do that. Okay. We'll have to figure out something with which we can easily copy paste it. If there is a right click that works here, it would have been great. So try using Python 2.x, Gaurav. So that's generally better than this one. Okay. Because most of our syntax will be using Python 2.x, not 3 dot versions. All right, let's start it. So like with any language, you start with the keywords, then you go with expressions, and then you start writing loops. Okay? So vocabulary, sentence structure, and story structure is the same thing. Let's see. So the portion of a Python program looks like this. All right? So you can see that the first statement, okay? What does it do? It basically reads a file from the user, and then text read and all of this. Okay, so what we can do is in here we can say uh, nano my program dot py. Nano is not there. Okay, let me try with pico is also not there. All right, I think I should just install nano on that. Okay, all right, so we can say nano my program dot py, and here we can paste our program, control X, save, and here is my program. Now let's say what goes here. It says enter file name, and we don't have right now any file name. So let's I'll just copy the file from copy to local data mr word count input big.txt. So I'm copying a file from HDFS to here. Okay, don't worry if you don't understand this command. So do you have this? Okay, we got big.txt file here. It contains some words. So let's try to run. So what I'm trying to show you here, that other than writing the program on the command prompt, okay, other than writing the program on the command prompt, we could also run program from here by saying, by writing all the commands in a file and saying and passing that as a first argument. If you pass no argument to Python command, it starts the interpreter. If you pass the first argument as some file which contains the statements, then it starts executing it. All right. For Python in Unix or anywhere, it doesn't matter what's the extension. It is just for generally Windows. Okay. All right. So you can see that I'm writing big.txt here. It says that the has occurred these many times. All right. So what exactly is it doing? Let's have a look. Okay. If you are comfortable with the VI, it's also a good editor. Okay. But to exit it, you'll have to. So I would recommend not to use VI if you don't know it. Okay. So out of this, it basically prints the word which has occurred maximum number of times. That's it. All right. You can say press escape, then do colon WQ. All right. Good. I hope everybody is able to get in. So Ashish, are you able to log in? Not yet. Not yet. So Ishwar, is your shell working somewhere where you can start Python program? Good, good. So go with the 2.x if you're downloading. Otherwise, you can go with Hadoop 3 or Hadoop 2. So, okay. So log in, please, Ashish, please log in. Do you see this page? From here, you can copy the password and you can go to console login, this one. Click on console login and then give give the copy this password and paste it there. Go to console login and then copy the password and paste it there. And login is Spark1. And in case you are going to type it instead of copy pasting, the thing that looks like I, it's actually L. Okay, good. Go ahead. So, Ishwar, are you able to hear me? Are you able to log in into the terminal? Harsha is up, Jitendra is up, Mehdi is up. Gaurav is up. Only Ishwar and Ashish has not responded well. Good, good. All right. So everybody ready with the terminal and is able to do hello world? Or let me just try to say nano hello world.py and say print hello world. Okay. Control X, save, yes, and that's it. And then Python hw.py. Good? So did hello world work for you? So for Mehdi it worked. Gaurav, did it work for you? Alright, so Jitendra, you are typing nano on the Python prompt rather than nano is a Unix command. So this is Unix prompt. And when you say Python, this is Python command prompt. You see triple arrows? To get out of this, you can say exit. Awesome. So it's working? Good. Okay. What kind of problem are you facing, Iswar? So in password, the L that you see there, the I, okay, the I, the second last character is not really I, it's small l. It looks like capital I. Awesome. So it's working for most of you. All right. So let me. So Spark 1 is the login, and that is the password. Okay. So the password is Jed. I mean, everything capital and small u. How to come out of nano is press Control X and then you can come out. Good, good. All right. So this is a little big program where we are counting. We are finding the biggest word and what was the biggest words count. All right. So you can define your own variable. Okay. So you can simply, let's just launch Python interpreter. So you can define any of the variable, whatever you want to write. Okay, except if the variable is any of these keywords. Okay, so we cannot define a variable like del. We cannot say del equals 10. Why? Because del is a reserved word. Similarly, other reserved words you can see lambda, try, return, break, global, and others. Okay, so here you don't have to define the data type. You can simply say x equals to 3, or you can say, let's say my variable equals some string. Okay, good. So except for the reserved keyword, you can define a variable name with any of the string. And there are few more restrictions. We'll talk about it. A statement when it comes to, so individual keyword is one thing. A statement is something like this. A statement is something which can run and does something. All right. All right. So everybody understands the difference between running it interactive and running it as a script. Great. All right. So are you able to write a kind of a script like, let's try to do is my principal is 10, rate is say 8%, okay, and time is 2 years. So my interest is equal to principal into rate into time divided by 100. So, and do one thing like this. Okay, so my interest is 1.6 rupees. All right, so here is a very small learning for us. So if you are dividing integer by an integer, the output will be integer. The decimal part will be truncated. Okay, so you can say, see that 2 by 3 is 2 0, but 2.0 divided by 3 is 0.66. Do you get the difference? 2 by 3 is an integer division. It's thinking of 2 and 3 as integers and dividing them. And the resultant is integer, which has no decimal part. But in case any of either the divisor or mm, the one which is being divided, either of them is a decimal, then it behaves like a decimal number. Good. All right. Now same thing you can also write in a file. Okay. Same thing you can also write in a file, and you can say cat my interest.py. Okay. And here one more thing you have to worry about. Sorry, let me try to do it again. There should be no space before your line. Okay. Earlier I was leaving a little space before my letter because for Python the indentation matters a lot. That's something which lots of new people find it irritating. Okay. And putting a semicolon at the end is just optional. So now we can say, all right, you want to see what is there inside interest here. So whatever I am working here, I'm going to, it would be visible to you, whatever my programs are here. I'll just put it in my folder in because it will bother you also. So I'll just move it into my own folder. Okay. In case you want to have a look at any of my data or program, you can simply move to Asgiri here. Okay. Good. So this is probably the easiest way to interact, that whatever I'm doing and I'm writing the code, I do not have to transfer it to you. It's there available to you right away. Okay. Also, let's try to see what all other errors you will do. So let's say in my program, not this one, nano, let's say interest. Okay. The if you leave a space before p, it will give you an error. It'll say there is an unexpected indent. Okay. So there is a purpose of leaving space before any of the statement. Therefore, be aware that do not leave the space before each of the words. Good. Everybody comfortable? So, all right. Where are you, Ashish? Are you inside Nano or inside Python, or where are you? What do you see? So to come out of the interactive shell, you can simply type exit, exit, and square brackets, round brackets. Okay. All right. So a program can be a sequential step like this one, where we did nothing, like in our interest computation, we did nothing, we kept on moving sequentially from top to bottom. But it could be a complex kind of a conditional statement whereby we are using if else statements. Okay, do you want to try this out? I think we should try it out. Okay, so here there is a single quote which will bother us. All right, let me just copy paste it. All right, let's say nano. Okay, if test. Okay, so what would it print? This program has if conditions in it. Okay, and there are few more catches to it which will give us error, and I think it's good that these error would occur now. Oh, it did not give error. Okay, now here you see the indentation space is uneven. Okay, easiest way to have is a tab. All right, so instead of putting curly brackets the way in other programming language, you want to mark that all of this is under an if condition. Okay, you said x equals to 5, which means assigning 5 to x. If x is lesser than 10, do this. And what all lies in this condition? Anything which has, after this statement, after colon has started, anything which has indentation space, indentation space of one tab. Okay, if I don't put an indentation space here, if I don't put an indentation space like this, it will give an error. Okay, all right, let me just get out of it. Let me try to run it. Now it'll give an error. It says that expected an indented block. All right, this is something people get uncomfortable with when working with Python. Okay, so what would it print? So Ishwar's question is, are there editors for Python? Yes, there are good editors. Almost every programming language support the syntax highlighting of Python. If you are in Windows, Linux, or Mac, the best editor is Sublime Text. Okay, I would personally recommend Sublime Text. But if you are a big fan of Eclipse and you want to stay in Eclipse, then there is a plugin in Eclipse. Okay, all right. Say for example, if I open the same program in VI, it will show you the colored syntax highlighting. All right, good. So a program might be a little complex one like this, where we are going from top. X equals 5 mean assigning 5 to x. If x is lesser than 10, print smaller. Otherwise, go to x greater than 20 and then print bigger. Otherwise, just print finish in all the cases. All right. This one is clear to everyone, although I have jumped a little ahead quickly. Okay. So a nano is a quick text editor. Okay, it's a text editor in Unix where we can type our commands and then save it. Okay, it's a quick way to get work done inside the terminal. Awesome. So moving ahead, now in certain cases there might be something called repeated steps. Okay, looping. You are all aware about what is looping. So in certain cases, you might want to repeat a certain step again and again many times. All right, you can say something like this. All right, let's try to create my first loop.py, and I'm pasting my code here. So it says n equals 5 while n is greater than 0, and there are some strange things. What is that? Where did it come from? The minus is not really minus. Now it's good. Alright, n equals n minus 1, and that's it. Okay, so we can say Python my first loop. See that? Good. So these are called repeated steps or loops, where what we are doing is it's a while loop. We're starting with n equals 5, and while n is greater than 0, we are printing n, and then reducing n by 1, and then printing at the end of all of the process, we're printing it. Now, how does Python know that loop has ended here? Okay, I mean, how does Python know when to whether to print blast off every time in the loop or at the end of loop? So let's have a look at the terminal. So if we put a tab here, okay, if let's say, let me just put tab, okay. Now if we bring print blast off to the same level of indentation, you know what would happen? The blast off will be printed as many times, okay. You see the difference? You see the meaning of indentation in case of Python? All right. Now this is a bigger program. Here there are multiple things to understand. First, we are reading input from user, okay, by saying raw input and then displaying something, and whatever user types after this goes into name. We open that file, okay, we open that file and then read the text, okay, read the text, and then we split the text and then count the words, okay. Create a dictionary. In the dictionary we are updating the frequency of each words, okay, and then we are, once that is done, we are printing it, okay. All right, you can try doing it one step at a time, okay. You can try doing it one step at a time. You can say file f equals to raw input, enter file. Okay, so if we write something like this, okay, let me get into Python. So f equals to raw input enter. Okay, now here we said big dot txt. Now the value of f is big dot txt. Now we can say, okay, handle handle equals open f. We are opening the file. You can see it's a handle to the file. So if we say data equals handle dot read, you can quickly see what is inside the data. It's little too much of text. It was a mistake actually. Yeah, never mind. Okay, so data contains all the words. So we can split the data and say just my array is this. So array has got length. We can say array. So there are these many words in this file. All right, sounds good to you? All right, and then there is a follow. We'll get into this after some time again. So it's a bit of a big program. All right, just to show you that there are statements. This is statement, and these are phrases, these are paragraphs, and so on. All right, so this was a quick summary of Python basics, as in how to get started with Python. We'll go into a little bit more detail now. Is everybody comfortable with running their basic Hello World programs? Mandy is able to do, Ashish is able to, I think Gaurav and Ishwar are also able to do along with Jitender. Gaurav, are you around? Harsha? Alright, brilliant. Good? So Ishwar's question is, in our course, how often do we use Python? We'll use Python quite often. Okay? Next is the usual operator precedence. So the operator like BODMAS rule applies here also. Okay. I will just go through things very quickly. If you have any doubt, please stop me and ask. Okay. These are all numeric expressions. The addition, multiplication, division, and doing the power. Power is double strict. Okay. So you can try that. You can say 4 to the power 5 or 6. Okay. And percentage is the remainder. This is something which we will use couple of times. So 4 percentage 5. What will be the output quickly? What will be the output of 4 percentage 4 what do you call this? 4% 5? We call it modulo. Correct. So you don't have to leave the indentation space before that. Yeah. And 6 by 5, 6% 5. All right. Now there's a question from Ashish. Question is, do we use double quote in our strings or do we use single quote? Both are fine. Both are perfectly fine. All right. And inside single quote, you can use double quote, and inside double quote, you can use single quote. So if your string actually contains single quote, you can keep it double quotes. If your string contains double quotes, you can keep it in single quotes. All right. So if your name is D Selva, okay, uh, something like D, you can keep it in the double quotes. Okay. Also, to comment out a particular, if you have a double quote inside double quote, you can put a slash and that will be taken as part of the string. Okay. All right. All right. So everybody comfortable with numeric expressions? All right. Next is the data type of things. Okay. So in case of Python, there is a data type of values. So when you say something like 3 plus 2, okay, is 32. Why? Because both of these are strings. If you say 3 plus 2 without double quotes, it considers them numbers. And if you are saying something like Sandeep in double quote plus Giri, so we are saying concatenate two strings. So the meaning of the two things is different. Now the problem occurs when we try to mix. It says that cannot concatenate a string with integer. Okay, so if you try to mix, then it's a problem. For this, either what we can do is we can say string 2, cast the data type of 2 into string. Okay, so every variable which stays in Python has got a data type, and in this data type is inferred from what value we are putting in. And we can quickly check the data type of a variable by putting type there. All right, we can say name equals Giri, and then we can say type name. Do you see that? And if you say val equals 30 and we say type val, the data type is integer. Okay, now if I put something of this sort and I say type salary, then it is float. Similarly, if our salary is even like this and 100.0, then it's a float. Okay, so you can quickly check the data type of anything by using type. Why is it designed like that? As in, you mean why don't we define something like int x equals 10? Is that your question? Okay, now it's a good question. Question from Ishwar is that why can't we simply concatenate like this? Why do you have to cast string to cast integer to string? Simply to avoid confusion. Okay, let's try to see that. Okay, let's say x equals to raw input enter x. Okay, we are taking value of x from the user. So now x is 3. We are saying x plus 2 and we are getting error. Okay, so in case it could have just appended 2 to x because x is a string instead of giving error, then it could have become 32, right? So basically, in order to avoid these kind of mistakes, it doesn't let you do or do the or concatenate two different kind of things. Now, either you might want to do integer of 2, sorry, string of 2, convert 2 into a string, and then concatenate it, or you might be wanting to convert x into integer and get the answer as 5. Okay, you can cast a string into an integer. All right, I hope this example makes sense to you. Is this font visible to everyone? Yeah, great, great. So Iswar, was I able to explain? All right, so this is the main reason why the concatenation simply doesn't work straight away, to avoid confusion. All right, moving on. Raw input takes the input from the user. Okay, so if in your program, if you, let's say I'm writing a program, what we want to do is just greet people. Okay, greet people. So we'll say name equals to raw input, and we say hello sir, what is your name? Okay, and then we say print welcome aboard. Okay, and name. All right, you can see that now. I say Sandeep. It says welcome aboard, Sandeep. Yes, by default the input is a string. For time being, yeah. Okay. If you have to take input as integer, you can cast that string into integer. Okay. The way we have done here, we took the input as raw input, and then the user entered x, and then we casted it into integer. Okay. For time being, that's a good enough. All right. Sounds good to you? So we talked about different kind of numbers. We talked about integers, we talked about float, okay? Also, we can convert a number into float if we want to, okay? So the way I was trying to demonstrate to you, we were saying 2 divided by 3 is 0, but if I say float, okay? You can see that now it is giving us zero point 0.6. Yes, we can do that, Ashish. His question is, while providing while providing while providing input itself, can't we give integer directly or cast it over there? Yes, we can do that. Okay. And hash means a comment here. Okay. Hash would not, if hash, any line is starting with a hash is a comment. So probably what you mean to say is, can't we do something like integer of raw input, something of this sort, right? Now, if you check the type of x, it's integer and x's value is 4. All right. There are methods directly from which you can read integer. Okay. Great. Moving on. All right. We have discussed about raw input. So a comment is anything starting with hash, and you can do the block based commenting using double quote, triple quote actually. Okay. So in case there are block based comments, you can do that using triple quote. I think triple quote is fine, right? So let's try to do. I've not used much the. Okay. So the other way to get out of the command prompt is by pressing. Okay. By pressing Control D, but don't press it more than once, otherwise you'll come out of the shell. So here you can. This is a comment, and this is. I think this is also a comment. All right. So that is also ignored. All right. So that whatever we have written in triple quotes is a block comment. All right. So we can write the block comments in triple quotes. All right. So sometimes when your code is not obvious, you should write comments, and your comment should be very precise. Ideally, when you are writing code, your variable name, your flow should be descriptive enough that you don't have to generally write comments. But lots of time it's not clear to the end user. In those cases, it makes sense to write comment describing what is it that you're doing. But don't write too much of comments because comments go obsolete more quickly than the code. Okay? Comments go very obsolete because there is no compiler which is checking the comments. Therefore, comments are generally obsolete in some little older code. So try to be very precise in comments. All right? We have talked about indentation. So after a block, as in earlier we used to put curly brackets, like the way we did after if statement or while statement, we increase the indent. If there are two if one inside another, then there will be double indentation. Okay, so indentation is very important in Python, and indentation plays significant role when we talk about the blocks of code. Okay, I have shown you already the meaning of indentation. Okay, unlike other programming language, this particular feature is far different from others. Okay, this is to enforce the code formatting. The better the indentation, the better is the readability. Even when we are discussing something or writing language, we do the proper indentation in order to in order to explain the context of things. Okay, even while I describe something in the plain text editor, I generally put bullet points in and well indented. That gives a clear context to the human brain. So that's the reason the indentation matters so much. Okay, so you can see that we can put I mean, in case of editors, if you are using a text editor, consider replacing a tab with four spaces. Okay, consider if you are going to use, say, Sublime Text. I use Sublime Text quite often. Okay, so this is my Python code. So you can simply say translate tabs to space colon true. Okay, here is my Python code which is doing something in Hadoop. All right, and yeah. Okay, so indentation in comments does not matter at all. All right, let's take a 10 minutes break, and also let's take a 15 minutes break, and you try to write this program. Okay, write a program to prompt the user for hours and rate per hour to compute gross pay. Create your own folder here by doing make directory and write your code in that folder. Okay, so you take hours, you take rate, and then you multiply the two, print the pay. Okay, let's take break for 15 minutes, back by 8:35 a.m. IST. Okay, so finish this. I think it should finish very quickly. All right. All right, so should we start? So, Mehndi, I was expecting that you will read the number of hours from the user, okay? And yeah, all right. So read number of hours from the user, rate from the user, and print it back. So has anybody been able to do that so far? Let me see if anybody else is using this. Oh, nice. So yeah, all right, good. All right, all right. Any questions here, or you need help, or should I move ahead? Great, great. All right. So the conditional statement we have already covered. Any questions on the conditional statement? Is this clear to everyone? What does this program does? This one? If you have any questions, just let me know. All right. A conditional statement could be a very complex. Okay. It could be very complex. It could be as complex as say one having multiple legs saying if x is less than 2 then do this it if otherwise if x is less than 10 then do something otherwise print this. Okay. So if you want to you can put the if else statement like this. All right, let's try to do that, and let's try to go into another tab and then okay, if complex. All right, let's try to run it. So let's try to also fix the errors that we get. All right, looks like good. Okay, so if x is if x is 1, what will be printed? Anyone? If x is 1, what will be printed? Quickly, please. Small followed by all done at the last. Okay, correct. Good. All right. Uh, just like many other languages, just like many other languages, Python provides you try and accept kind of whereby you could you could write the try and catch kind of statement. If you are executing something and you know that it might fail, so what you need to do when it fails, that kind of thing you can put in try and catch. Okay. So the general very straight structure is the let's try to write something like a very simple thing. So here we are taking the input from the user, okay, from the user, and then we are trying to cast it into integer. What if this variable does not hold an integer, it has something else? Okay, so you can see that we can write try catch in the sense that we first convert it into integer. If that fails, the control jumps here and we assign the I string number to with -1, and after that, okay, after that we can use I string as usual. Otherwise, if we do not put try except, the error in casting would cause the program halt and your program may not function correctly. Okay, so let's try to do this. If you see here, I'm Giri, and then I can say nano and cast test.py. Okay, python cast test.py. Okay, so it says that first is equal to -1. All right, because, or you can say here, we can say raw input enter number. Okay, enter number, and here we can, in the accept, here we can also say print invalid input, assuming it to be -1. Okay, in case you get into the mode where you can't see the command prompt, you can press Ctrl L and the screen will be clear. So it's asking for 12. This is fine, but the moment if I say something like this, it says invalid input, assuming it to be -1. Okay, and then it assumes the value of the number as -1. So everybody clear about try and accept? And like with any other language, so to handle the errors in the program, if we do not, if let's say for time being, let me just comment out, let me just try to comment out, let me just comment out something of this sort. Okay, let me also, I'll rename this file, and note that when we are removing try and catch, we have to, okay, change the indentation. Okay, so we have named it with a different one, we have put one after this. So it, when we entered something invalid and have not handled the error, it, the program just breaks, it does not go forward after the int method. All right, it says that invalid value, because we are typing ss, it invalid value for int with base 10. Base 10 as in we are trying to convert this number into decimal number. Okay, so the, the int function is giving us the error. Okay, in function is giving us the error. To handle that kind of error, we are using, okay, to handle that kind of error, we can use try and except kind of syntax. I put comment out as in remove the try except. In those cases, the program did not progress after this point. All right. So this is how you generally do the error handling. So wherever you are suspecting an error, we put try and accept statement. And also there is a full philosophy of kind of exceptions, as in every program can throw different kind of exceptions like invalid, string format exception, file not found exception, and so on. Okay, those things you can catch independently. You can mention that except in this case, in case of invalid file, do this, and in case of other files, do that. Okay, so basically every function, when it fails, it throws exception. Exception is an object. Okay, it throws you an object containing the detailed story about what went wrong. Okay, so similar kind of object you also can throw from your program in case of errors. Okay, so earlier, before the errors, before the exceptions, the only way to convey to the end user was by the way of returning values. Okay, when we talk about functions, we'll talk about that. All right, so everybody clear till this point? So this is another program from here. Okay, all right, good. So you can try this. Okay, you can try this program. And okay, so now you can improve your program whereby you were trying to do the computation. Okay, you can augment your program with exceptions, as in when the user is entering number of hours, do the check. Okay, if the user is entering the rate, then do the check and show the error. Okay, now it will be up to you whether you want the user to you want to assume something in case of error, or you want to prompt the user to enter a valid value again. Okay, so those kind of controls you can do here. In case the user has entered some invalid value, if you want him to do enter something else, or if you want to assume something, you can do everything inside try except. All right, so there are comparison operators like equals. When we were talking about if else, we did not talk about the comparison operators. So the I think a better way to do a comparison operators is from the prompt. All right. So let's say x is equal to 6. When I say single equals, it means we are assigning things. So you can see x, when I type x, it is showing us 6. If I assign it 60 into 4, the value of x is 240. All right. Now, here I don't have to type print generally, but if you are using Python 3, you'll have to write print explicitly. And so here we have got some value inside this box called x. X is a big variable containing value, and x's value is changing. Now, coming back to the point which we were driving. So if we want to compare x with something, we can put equals operator. If we say 240, it returns true. Okay, this is an expression. So every expression results in something. This expression is resulting in the Boolean operation. Okay, it's returning a boolean value. All right. If I try to say x equals to 340, it says false. So such boolean expressions we can write in the if condition. Okay, and we can say if x is equals to this, you can say print awesome. Okay, else print horror. Okay, now if you press double enter, it will execute right away. All right. If our x was 100 and we are using the same condition, if we are using the same condition, then we could have got horror. All right. Sounds good to you? Great. So there are other Boolean expressions saying x less than 200 is true, x less than equal to 100 true, x greater than 100 is false, greater than equal to 100 is true. All right. And we can also say not equal to, and we can also put or x equal to 100. Or we can say x less than 100 or x equal to 100. That's also true. Okay. And we can say and x, and we can also put the conditions like and. If you put condition like and here, what would happen is we'll get answer as false. Okay. So and is basically the logical and. So if you want to say x is 10 and then we want to say x greater than 10 and x less than 200. So is this true or false? Yeah, Gaurav, Ishwar, Ashish, Jitender, Mehndi. So if x is 100, then this condition, what does it mean? True or false? You could put brackets around it as well. And then you can say and x not equal to 99. Now, true or false? Quickly, are you sure, Mehdi? Our value of x is 100. So this expression you see here, see the expression now? X not equal to 10 and x greater than 200 and x not equal to 99. Correct. The answer is true. Alright, so everybody comfortable with the expressions, I'm assuming. Correct me if I'm wrong. Great. So you can put complex if inside ifs as well. All right. All right. Now, a lot of times, like the way we were doing here just now, we were having difficulty in calling this block on different values of x, right? If you have to call some block of program again and again, some input, then that block of program can be created as a separate function and used against certain input. All right. So function is very important construct, and using functions we can do a lot of magic. Okay. Using functions you can do a lot of magic. All right. So basically, if you, I'll write some meaningful code. I'll try to write some meaningful code, something that is interesting. So let's say I'm writing factorial. Okay. So inside the factorial, what do we do? First, we take enter number. Okay. So I say n equals to integer of raw underscore input, and I'm asking for a number. All right. Good. In case you're not confident enough, you can parallelly start your shell like this. Let me just start writing it parallelly in the notepad. Okay, good. So I'm just keeping a track of whatever I'm typing. So good, it's working. So if I see the value of n, perfect, this is working. All right. Now we can put a condition here saying keep on asking for a number. We can put a loop. Now we have to compute the value of a factorial. Value of a number, we have to compute the factorial. For this, what we can do is we can define a function called factorial. Okay. And and pass the argument. All right. If n equals to 1, we are returning a value of 1, else return n into factorial of n minus 1. Let's see, do you think it will work? Let's first define the function here like this, and then next thing we'll do is we'll say print factorial of n. Sounds good to you? Or let's try to do that here right away. Let's define the function here. Factorial of 1 is 1, good. Factorial of 2 is also 2. Factorial of 3 is 6. Factorial of 4 is 4, good. Factorial of 5 is good. 6 is good. Does it make sense to you? Where so Ashish is saying I have used triple quotes. Are you where have I used triple quotes? So these are double quotes, yeah. And this one, do you see here these triple dots? These are being displayed by the prompt itself. If you write something like def x, it automatically start displaying dot. Okay, so all right, so is this function clear to everyone? If you have any doubts, please let me know. So we are creating a function called factorial, which takes an argument as a number. And in case if this is n equals to 1, then return 1, otherwise return n into factorial of n minus 1. Alright? So we can again save it as a program. Okay? And a quickest way to save something as a program in Unix, you can use this kind of a syntax. Alright? Good? Why did it ask twice? Why is it asking twice? Oh, I think there was already some file which was having this statement. Good. All right. All right. So this is quite clear to everyone, right? If you have any doubt, so this is the argument which we are passing, and we are returning something from the function. Okay. A easier function could have been something like summation of x comma y comma z, or we could say return x plus y plus z. Okay, or let's define a function called min x and y, and we are returning x, uh, return if x is greater than y, return x, return y. Okay, so is this clear to everyone? We can quickly define such kind of functions, and you can see min of 4 comma 5 is, sorry, that's a max we have coded. Okay, minimum of 4 and 5 is 4, minimum of 40 and 5 is 5, and so on. Okay, sounds good to all? Also, can somebody tell me what does this program do? Okay, define my func. Okay, it doesn't take any argument. It says line equals to raw input, raw input, and enter something. Okay, if line equals to say dot dot, so say hash. Okay, if line equals to hash, print line, else print else my func. So let's say there is this function, nice function, and what it does is, can somebody help me understand what does this program do? Oh, sorry. Let me try to write it again. Yeah. So now let's take this program and define it. So yeah, can somebody tell me what does this function do? Anyone? Okay, Ishwar says that till you enter hash, it keeps asking for input. Good. Actually, this program would reverse the lines in the input. This program will reverse the line in the input. Okay, let's say first, second, third, fourth, and do you see? Do you see? Fourth, third, second, first. Sounds like magic. How did that happen? So it first read first, okay, then again called. Right now the function is stuck here. It has not come here. So the first call goes onto the stack, then second again we entered second and so on. And the moment we print hash, the the function starts returning and the individual values of each individual call keeps on getting printed. So line is a string. Okay, line is a string that is being entered by the user. Okay, so I know that you have not got it. So please ask exactly what happened. So okay, it took me some time to actually figure it out. How is this working? Okay, Ishwar and Gaurav got it. All right. If you have, should I explain it again? All right. So for the first function call, it reads the line And then, okay, so let me try to call it on maybe. Okay, so for the first function call, it reads the line, right? And now it has encountered that line is not hash, so it's going to call again. So the function has been called from within the function. So first function was called for the first time, my funct was called, and then my funct is calling my funct. So which means when my funct returns, it will come back here and start printing from where it was. So where it was, the line's value was first, okay, and then first will get called. When it returns from here, then first will get printed, okay. So right now my funct is being called again. So here I type second. Okay, so line equals to second and is being done. And now again, this my funct has been called. Okay, if I put hash now again line we are here and I'm putting hash here. Now the moment I put hash, it will return, the function will return to the another function call where the line's value was second, right? And then it will print that line which is second, and then it will go back to the previous function call. I mean, it'll go to its caller who called my funct called my funct, right? So that's how it is. Sounds good to you? So so it's not my line which is storing anything. It is the function call which is storing things. So when one function calls another function, okay, when one function calls another function, its values are stored. You can think of there are three functions, okay, my funct and another one and another one, okay. So that's how it is. So on my first function call, line's value is first. Then we call this function again. And so a newer function, a fresh instance of the function has been called, and then you entered another value again. So that value is a part of the new function, right? Did it make sense to you now? So there are a lot of magic that could be done in in a in a very small code using the recursion, okay. There's a lot of things that could be done using the recursion, a lot of magic, specifically the way we think, as in, okay, let's try to compute this value, and the way we have done factorial, okay, the way we have done factorial is quite a good example. So in case of factorial, you can see that the value of n, every time we call a function, new instance of variables are created, okay, and those variables remain, their life time is till the function is being called. Did it make sense to you? So you can think of it like this, okay. This is our first time we called, the line was equal to first, okay. Then we, and let's name this box. The box's name is my funct, okay. Now the same thing has been repeated, same thing has been repeated again. Okay, again here when we are calling, again when we are calling the my funct, it will basically make a call to another function, and there the value of funct will be second, right? And once it has printed, and this is the way you can visualize it: print line. Okay, and again the line is second, and here there will be print. So this particular my funct is making a call to the new one. And then if you look at it carefully, okay? So now if you see, third will get printed and the control returns here. Third gets printed and the control returns here. And then second will get printed, and then from here, when the work is over, the control returns to the previous one. So third, second, and first will get printed. Now is that clear to everyone? So for the first time, the function gets called, the line value is first, then again the function call is happening, then the second and the third, and then hash would be there the next, but I have not, because of the leg space, I have not included that. And once the third gets printed here, after the line is over from here, the control returns to this, the location from where the function was called, and this way. Clear to everyone? Yeah. Everybody with me? Great. Ishwar, Mehdi, Harsha, Jitender, Ashish, Abhishek. Great. So I hope this is clear to you. This is because this is a very important aspect. We will use recursion multiple times in future. Okay? All right. All right. I think arrays I have not covered yet. Let me just go briefly over arrays. Okay. We will go into, maybe if time permits, we might go into arrays. But yeah. So here an array is something of this sort. Okay. So we can say A equals X comma Y, and then we can have multiple data types into an array. Okay. Also, those who are getting a little impatient and waiting for the for loop, we I've shown you how to write a while loop. We can write while loop, and let me just go over arrays, and then we'll go into a little bit detail more. So to access a particular element in an array, we can index it like this. If you want to access the range of values in array, we can say things like this. Okay, so we are saying give me all the elements starting at 0 up to before 2. Okay, meaning give me two elements. All right, in case the we are asking for a bigger range, it will not give error, instead it will give up to the length. Okay, to find out the length of an array, we can say lena. All right, so we can say lena, and in case we want all the elements after a particular point, we could say things like this. So if we want only two elements out of a, we could say a colon 2. If we are looking for the last elements after 2, we can say 2 colon. Okay, if we are missing something so when we say a 0 colon 2, it says starting with 0 and two elements, but if we miss out the first value, it is implicitly 0. Okay, and these are very useful constructs. If we are if we miss out the second value, if we miss out the second value, it means everything after the first index. And first index is y. This is 0, x is at 0, y is at 1, and so on. Okay? So when I say a 1 colon 2 means start with 1, print two letters. Or I can show you again. Start at 1, give me two elements. Okay? And if I say this, it means give me all the elements starting at first index. All right. And if you want to add more elements to an array, we can say a append 3. Okay. As well as we can assign to a newer index. Say say we want to add a fifth element, we can say things like okay, sorry, that is not allowed. So if you want to access a particular element, all right, we can only append. Unlike, yeah, I completely forgot. I started thinking about JavaScript. So we can append more values into A by using append, and we can easily get a sub array by putting those kind of syntax. All right, we can quickly do the sub array. Similarly, most of the syntax with string, we can use the array like constructs very easily. Okay, because a string is nothing but array of characters. All right, so you can see that we are doing sub array quickly. Everyone with me? Construct as in construction. Okay. So we can basically use this kind of array suffixes for the various roles. Now let's say we have to find, okay, find sum of an array. Okay. So if you have to find sum of an array, what will you do? You will basically iterate over elements in an array like this. Okay. So there is a while loop and there is a for loop in Python. We have covered while loop earlier. The construct of a while loop is while, condition, colon, and tab, and then the statement. That's all. This is the while loops construct. And the for loops construct is for I in range 0 to 10 and print I. That's it. Okay. So while loop is infinite loop, indefinite loop, meaning it may or may not end because it depends on the condition. If you got the condition wrong, the while loop will keep on going indefinitely. While if you have a for loop in case of Python always ends. For loop means iterate over list of things. Okay, you can see the for loop. So we are first, for loop, we are first generating a list of values and then iterating over them. So for loop is definite loop while loop is indefinite loop. Okay, you can see what does it mean by range. You can see the what does it mean by range. So range means starting with one before um, starting with a value before the second value. So you can see that. So range generates an array of values. So for loop essentially iterates over an array. So if an array is apple, orange, and guava, okay, and I say for fruit in A, print eat A, not this. For fruit in A, eat fruit. Okay, does it make sense to you? So for loop, unlike C, C++, Java, and everybody else, the for loop here is only an it only enumerates the values. It does not really uh, do a conditional looping. It's a definite loop. For loop is, when you look at for loop, it is supposed to always end. Okay, so that's a different feeling about a for loop, because if you remember our C, C++ kind of a cases where when we looked at for loop and while loop, we were always very we were always wondering why do we have two kind of loops. Okay, that kind of problems are those kind of things are not there in Python. For loop means it's basically an iterator. We only iterate over the list. Okay, and in case of a while loop, let's say uh, we want to say print I equals 0, and we say while I less than length of an array, which is a, print print eat, let's call it eat in while, and I say a and I. The same thing, if you see, we made a mistake and it's going in the loop. See, we made a mistake and it's going in the loop. And what mistake we made? We did not increase I. We did not increase I, and therefore it's going in the infinite loop, which I'm not right now able to cancel. All right, which I'm not right now able to cancel. And you can see, is this the one which is causing a lot of, okay, it has been killed already. Let me try to refresh it. We'll connect again. Spark 1, and let me just copy the password and paste it here. All right. So we were talking about an array of things. So we are talking about orange, orange, and guava. Also here the single character doesn't mean much. So we could write I equals 0 while while I is less than length of array. Okay, print element at ai, and also increase I by 1. Okay, so sorry, yeah, print ai, and here I plus plus is not there, so we'll have to increase by 1. Now you can see that apple, orange, and guava, AOG, is printed. So this is how you get it done. All right. So here is one question from Gaurav. Gaurav is saying, how can we iterate from second of to fifth element of array using a for loop? So you can do things like, let's say there is an array. Let me just show you. A equals, let me just generate an array of 10 elements. Can you see that? Starting from A before 10. That's what range generates. So if I have to iterate from second to fifth, I can simply say for I in A, starting from second up and 3 more elements, and print I. Okay, sorry. I can say, yeah. So for A up to 5, print I. You can see that. All right. So we talked about two things. One was while loop. Okay. One was while loop like this, where we say things like I equals to 0 and then put some condition like I less than length of something and so on. Okay. Now let's try to do a couple of things. Let's try to find an area of the circle without using the area formula. Sounds good to you? Okay, let's say the radius is 1. Radius is 1. And what are we going to do is we are going to split this area, split this. So let me try to sketch it up if I can do. So we have to find, our next agenda is to find area of circle. You remember our yesterday's discussion where we were trying to find the area of circle, basically the value of pi. Okay. So area of circle is A equals to pi into R into R. This is the formula which is known to us. Let's say that we do not know the value of pi and we want to find out the value of pi. Okay. So what we do is we first compute the area of circle. And how do you compute the area of circle? Let me try to demonstrate to you. These are very important concepts when it comes to the distributed computing. So let's say area of circle, as in a circle will look like this to us. Okay. Okay. So if the radius of this is 1, if the radius is 1, okay. So this will be the area of the circle. A circle will be inside here. This is the area, right? Here, this all of this is area. Now, if you have to find a way to, if you don't know that area of circle is pi r square, how do you compute this area? Okay, one clever way, I mean, not really clever, but yeah, if one way is to split this into a grid, into a grid like this. I'm not able to draw it correctly. So, like into a t- say 10 by 10 grid, let's assume. Okay, and then what we do is we compute the sum of this, sum of all the squares which are inside, which basically compute the sum of these values, sum of the area of these squares which are inside, which are inside the inside the circle. And how do you know that something is inside the circle? By checking the value if x square plus y square is equal to the r square. Okay, so let's say the center of this thing is at 0 0. This is 0, this is 0 0. Okay, and we are starting from -1, we'll go up to +1. Similarly here also, uh, uh, this is -1 -1. If you think about coordinate system, this is x-axis and this is y-axis. Okay, this is y-axis. Okay, so if we iterate over these values, then we will be able to compute the sum of, compute the area of the circle without having to manually do it. Okay, without having to apply the formula. Is it clear to everyone, this approach? No? So it's only clear to Gaurav. All right. How should I? Let me try to explain in a better manner. So, all right, look at this. So this is our circle, right? Right now, all we have to do is find out the area inside the circle. Okay. So if we basically split this circle into very smaller pieces, okay, like we put it on the graph paper and we try to compute how many squares are there inside the circle, right? And we know the area of a square, right? The length into width. We basically just have to count number of squares. If we put it on the graph paper, we basically do divide it into a lot of sections, and then count how many squares are there inside it, right? And become the area. That is the definition of area, right? So 1 2 3 4 5 6 7 8 9 10 11 12 and so on. If you count all of these squares and assuming the one which are on the corner, okay, so when you are counting half of the square, it's okay. Okay, if the squares are very small, these errors will not make any difference. So here you can see that this is half of the square. It's okay to count it. It will not make much of a difference. Make sense to you? No? So our objective, if we can basically count these squares, then that should be good enough. Okay? Harsha? And how would we count these squares and how would we know whether a particular point is inside the circle or outside the circle? So so in case a point is inside the circle, its distance from the center would be lesser than r, right? If something is inside the circle, its distance from center will be lesser than r. That you can compute. The distance from the circle you can compute. Distance from the center you can compute using Pythagoras theorem. Okay, using x square plus y square, square root of it. So that will be the center of the. Okay, so you can compute the area of circle that way. All right, and that's what we were doing. So what will we do is, so we'll do for I in the range of -1. Let's try to do. Let's say we are splitting radius into 100 sections. Okay, and we are saying while I equals to -1. So we start with I equals to -1. We're going on the x-axis. I equals to -1. Starting with -1. I less than or equal to +1. Okay. Similarly, we start for each of the coordinate, we start at y coordinate, or you can say x here. That'll be easier for you. So we say x equals to sorry y equals to -1, okay, while y is less than equal to 1, and then do something here. Okay, if inside if x and y are inside, then count plus equals to 1. Okay, the, if these x and y points are inside, then the count we are increasing. Okay, all right, and then we are increasing y by y plus equals to, let's say we have defined the step size as 0.01. So we are increasing y by step, and again x by step. All right, now we have to also define, so this is our count function. Okay, let's define get underscore count. Okay, this will give us the total number of counts. All right, now let's define inside function also. What does it mean by inside? If uh, so for x and y, the distance from the center will be sqrt of x into x plus y into y. Now, when we are doing this, let's check, is sqrt a function or not? Okay, let's check sqrt is a function or not. So sqrt is not a function. It's so we have to import math, and then we can try. Okay, we can say something like this. See that? So which means we have to change our code first to import a library called math. Okay, so we are importing an external library called math, and then we are calling math dot square root on top of this. Now let's try to do this. Let's try to see, does, so let's just try to see inside -1 comma -1, which means, does this point, okay, let me also return some value out of it. If r is less than or equal to 1, or we can just return, if r is less than or equal to 1, we return true. Okay, because radius is 1, else we return false. Okay, so we are doing a lot of things here, so stay tuned. It's very very important right now. So you can see, if I have to check if my leftmost point is inside the circle or not. Okay, if you go here, I'm talking about the point here. Okay, so we have put the center here, and -1 here, -1 plus 1 plus 1 -1, and +1 +1. So on the coordinate system, our origin is at the center of the circle. Okay, so we are saying inside -1 meaning left bottom is not inside this, is zero zero inside it. Let's try zero 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 zero. Yes, that's correct. 0.5. Yes, that's also true. So our inside function is perfect, working perfectly fine. Okay. So now once we are done with everything, we'll return the count. Okay. Let's see what happens. So I'm saying counts are equal to get underscore count. So you see how many. So these many squares are inside the circle. And how many are total squares? How many are total squares? 100 into 100, which is 10,000. No, not 10,000. 100 into 100. Yeah. Is there something wrong which you did? We are adding step, right? No, it's 200 into 200. It's 200 into 200, which is 40,000. So out of 40,000, there are only 31,000 squares inside the circle. Okay. And what is the area of each square? So the area of each square is zero point zero 0.01 into zero point zero 0.01. Area of each equals to zero point zero 0.01 into zero point zero 0.01. So area of each is this much. And if you multiply this with area of each, you get 3.14. That is the value of pi. Because area otherwise could have been a equals pi into 1 into 1. Right? I think everybody is I've lost everybody in this discussion. Anyway, I'm just saving it in case you want to try it out. You can try it out. Okay, so we can say print get underscore count into step into step. Now let's just create a proper program. We call it area.py. Okay, so here we are, and let's try to do that. Okay, let's try to take this line outside. See that? If we keep on increasing the, if we keep on decreasing the step size, let's say we decrease it to this level or maybe this level, we will get more and more precision into into the into the value of pi. Okay. Now, since we have decreased the steps, it might take a lot of time. And that's where, since it's taking too much of time, Even though the data is small, we might have to use the distributed computing. Okay? So all we did was we took a big circle, we cut it into very small pieces, and then we counted these pieces. How many squares were those? Assuming the one that are at the corner, which are half cut, which are on the boundary, if we even if we count them as a half, okay, or do not count them, still it's a valid. Still the value is valid. Are you with me? So we basically took a circle, cut it into small pieces, very small pieces, where the ones which are at boundary and which are cut into half can be ignored, and still the value is valid. Okay? So let me try to do a little lesser. So as we keep on decreasing this value further and further, okay, it'll take a lot of time to get it done. Now you see, the value of pi is getting closer to the reality. If you go search value of pi, okay, you see, we are getting closer to it as we are decreasing the size of the slice. Do I make sense? All right. Now, as we keep on decreasing the size to for the precision or for any of these kind of problems, we will end up with the limitation as CPU, as I just showed you that it was not yielding any result when we decrease the slice size by 100 times. Okay? Because it has to compute, it has to iterate over billions of squares. And that is when you can utilize the distributed computing. And how would you do the distributed computing? You basically first cut the big cut the big circle into maybe 10 blocks, and then hand over these 10 blocks to different machines to get the work done and bring it back to the central place. And that's what we showed you an example yesterday. All right? Does the distributed computing make sense to you? Does Spark make sense to you? Because if you just try to decrease this one by one more zero, okay, meaning you are increasing total number of squares cut out of the circle by 100 times, and that's when it takes forever to get the results. Okay, so that's when you realize that either you need to go for a supercomputer or you need to go for a distributed computing. Here, this is the classic case of CPU becoming the limitation, not the RAM. In our word count problems, the RAM would become problem when the data becomes bigger, and in case of in case and also the IOs become a problem. The ability to the pace at which we read write the data, that becomes the bottleneck. All right. So I hope I am able to do the justice, and we are moving ahead with a couple of more very good ideas. So we have already covered this by examples. So a function has a definition, as in it returns a value, it takes argument and the name of the function. And a function is like a big machine which takes the input and gives the output. All right. And that's how you got to think about a function. Now, functions can have variable arguments. So you can write a program that can function such that you can count the total number of argument. Okay. All right. Now, basically, in some functions, you might have this flexibility. You want to give to the user that they can add as many argument as they want. Although you can always say that please pass the argument as an array and I only accept a single argument. But it sometimes makes sense to give them the ability to put multiple arguments. So in those cases, you can put asterisk and you will get arg as an array. Okay. Sometimes you want your users to give this functionality that no matter in what order you key in the arguments to my function, as long as you prefix them with their names, then it's good enough for me. In those cases, you can use kw arguments, keyword arguments like this. If you put double asterisk there, you will get sort of a dictionary there. All right. Now sometimes this is very important, probably in the context of distributed computing. Probably these few things are very important. So sometimes you want to pass the functions as argument. Let's say let's say let's say we are writing this nice thing, and so just now we wrote something, right? We wrote a program here. What was that? Area.py. Okay. Sometimes you have these kind of programs where you want to pass the arguments as functions. Let's say you have, all right, you have this kind of function, and what you want to do is you want to, instead of hard coding that what function will be used as inside, you use myf. Okay. And that's where the complexity starts. Or let me try to simplify it. Let me try to write a quickly a function. Okay. Let's say there is a function called isValid. Okay. There is a function called isValid, and it does something. Let's say if is equal to 0, it's divisible by 2. Okay. Now you are writing something called cleanup. Clean up my data. Okay. Clean up data, and there you can write validator as the argument, and there is an array. Okay. So you can say for a in, okay, let me just make something really quickly. For a in array, array is just my input array. Okay. So for a in input array, if validator a, then we push it to output. Otherwise we don't. Okay. And in the end we return output. Do you see that? Now you see this here. What we have done is we have taken out a condition, a function, and made it an argument. So we can pass a validator function as an argument. So what does it do? It iterates over an array, and then for each element it checks whether the validator is returning true or false, and if it returns true, then it basically here there is a mistake, so we'll say output dot append. Okay, all right. So let's say we are defining a function called isValid, and we are cleaning up an array. Now I think when you see the result 1 2 3 4, and we are saying isValid. Now do you see what happened just now? For each element, for each element of this array, we called isValid, and wherever isValid is returning true, we have put only those values in output. Now you see, we are able to inject, we are able to pass the functions as if it's a data. The way we passed other argument, we also passed a function, a pointer to the function. Make sense to you? So this is passing the things as argument. And how does it matter? All right, how does it matter? This makes our life really really simple. Okay, let's say you had to let's say you had to do something really small, something like find, compute sum, right? You had to compute the summation of some values in an array. Okay, and what you want to do is the uh, compute sum, and you can only do the summation of only two values at a time, right? You can only do summation of two values at a time, let's say. We all know that, right? One way is we basically iterate over an array from left to right, and keep on summing up. Or the second way could be that we take two values out of an array. Okay, we take two values out of an array, and for each two values we call the sum function. Okay, we say take sum x comma y, and we return x plus y. Okay, now we could take two values in from the array, and then we can start computing the summation, right? All right. That way, if we made it such that we are basically computing the values two at a time, then we are able to solve a lot of problems, right? So let's say my initial, I take something like a, my first sum equals to array zeroth element we took. Okay, and then we went ahead for a while I equals to 1, while I less than length of an array. Okay, and we kept on saying sum equals to sum of sorry, let's call it something else. Let's call it base return value. Okay, so return value equals to return value equals to summation of previous return value and array of ith index. Okay, and we do not forget to increase value by 1. Okay, so what we are doing here is we are defining this. First let's define our own summation function. Let's define our own summation function so we can just test whether it's working or not. So it's working fine. Now let's take the second function, which basically iterates over an array. Okay, which iterates over an array and does the computation, right? Now you see that we can simply say 2 comma 3 comma 4, and oh, we forgot to return the value. Yeah, we forgot to return the value. We say return ret value. All right. Okay, so now you can see compute sum, and we pass an array 1 comma 2 comma 3 comma 4. You see, it has computed the sum. Now you realize that, hey, I think we can make what we can do is, instead of hard coding sum here, we can pass it as an argument and then call that function, right? Call that summation function. So what we do is we basically have externalized our sum function, and we are passing sum as the argument. So sum is saying that sum only takes compute sum only. Sorry, we have to say compute, not compute sum. Okay. So you see that now after some time you realize that we could actually use exactly same approach to compute the minimum also, right? We could do the same thing for finding the minimum value. So what you do is you write a function called define minimum x comma y, and if x is less than y, return x, and else return y. Right? Now let's define this function, and instead of passing minimum, we will pass we will pass not else. Let's just do this way. Okay, yeah, this is good. All right. Did I make a mistake? It should be okay now. All right. So we can check whether min is working or not. We can check min is working or not. Perfect. Now we don't have to write this code again. Instead, we could simply say compute compute minimum of these values 1 2 3 4 5 6 7 whatever, and then use my min function. Okay. Now this slight change in the approach suddenly did something miraculous. And what was it that was done? It basically made it possible to carry around a function to the data. What is happening here is we are saying compute. Okay, so this computational machinery, this becomes an independent machinery which can be part of the framework, and your function could basically becomes a piece of code which can travel to the data. So we are applying this minimum function on this data. All right, so suddenly we have shifted the paradigm from our normal way of iterating through the records to applying an external function on the data. And that's what leads to a lot of distributed computing. And these things were part of the functional programming for quite some time. All right. So So these functions, the one which we have just done, are also provided by the Python library itself. So there is a function called filter, which basically applies your function on uh, on on your array. So you could define your is-even function, and you could use an inbuilt function called filter in order to just filter out those values. Okay. So instead of writing loops, you are basically utilizing frameworks way of doing it. Now internally, how does filter iterate over the array or the data is not your headache. Okay, you have provided your function for computing the is even. Okay, similarly, you could also have something called a map. If you want to apply your function over every element of an array, then you could use an inbuilt function of Python called map. Okay, and these MapReduce were there even far before then Hadoop or MapReduce came along. Okay, these maps were far before than what it was earlier. Okay, so now let's have a look at it. What we are trying to do, we are trying to say this is my array, and please apply my function called my map on each element of this array. Okay, so you're applying your function on top of data, and what does your map function do is it basically multiplies every value by 2. Sounds good? So it executes a function on each element of an array. Now, similarly, the way we had demonstrated you, that's actually the reduce function. The one which we just demonstrated you here, the compute, okay, where we are picking up two values at a time and applying your function to convert those two values into a single value. That's a reduce function. And the reduce function is also inbuilt into Python. Okay. So instead of you writing the loop, you leave it to the framework to do the looping or the iteration of the data. Okay. So you can see that we are using reduce on top of our data. You see, all it does is it'll take two values, apply your sum function, then it becomes 3, then 3 plus 3 is 6, and 6 plus 4 is 10. Sounds good? No? So only two more slides left. All right, there are actually more slides than I was expecting. All right, these are good functions. Actually, we can take it later. All right, so that's pretty much about Python. I'll not go into too much of detail about Python. You all right? I will give you some book with which you can go further, or you can just go through as and when required. You just search for the library and start using that library. All right, sounds good to you? And the way we were doing here is, so if these are the values which we are having in the reduce, we'll take it in the next session. All right, and yeah, okay. It will be available, Jitendra, in the session, in the session number 3. All right, no worries. All right, good, great. And I hope you guys enjoyed the session. And if you have any question, please feel free to get back to me. Okay, and yeah, and also please provide me a feedback, as in, um, is it going too fast, too slow, or out of context, difficult problems? So let me know what is it that I need to tune. Okay, because I had been programming for probably 15-16 years, so there are few things I quickly skip, and later on I come to know that, oh, I did not emphasize on certain part, or something which I think is very important I keep on elaborating. Those things I need a feedback, so please provide me the feedback. All right, I look forward to your feedback. So Ishwar is asking for a coming week off on Vinayak Chaturthi. It is a long weekend. All right. Although it's very difficult, but yes, I can drop an email to everyone asking and then confirm to you, Iswar, because this is a small batch, so we can consider that kind of thing. But I'm not sure if people will like it. All right. So we can I'll drop the email. I'll drop an email to everyone and ask. Okay. because there are some people who are not here. All right, have a great day. Bye bye. All right, great. Bye bye. And please, please provide me a feedback. I do need your feedback in order to improve. All right. Okay. This document will be available in the session number 3 here. All right. And all my exercises are in my folder. I'm going to put all my exercises here in my folder. I've already done some work here, and we can put all of this into another, and my distributed code, I'll just put it in a single file. All right, so you can have a look at it. All right, I thoroughly enjoyed the session. Okay, so regarding notes, okay, let me just make a note. Let me just drop myself an email saying send upload PPT and upload notes. Good. Thank you very much, Ishwar. Have a good day. Bye bye. Thank you, Gaurav. Thank you, Ishwar. Thank you, Ashish. Thank you, Jitender. Thank you, Mehdi. Please do provide your feedback. I definitely need it in order to improve the sessions. Okay. Bye bye. All right. Thank you very much.